Alright, this is a real quick video for the UFO Imperial team. We've moved our equipment inside because, sorry, I was getting quite frustrated working out in the heat. Anyway, what we have here, of course, we have our UFO motor, our generator head, and just for later on possibly a 100-watt light bulb to give you a test. I'm using John Stone's Superior driver circuit. I've taken out the two DC-DC converters that I had in place for another design that I was thinking of, and just because I know, Dana, you're going to ask what I've got on the back of the circuit, you can actually see I've stuck a big old thick piece of copper wire from drain to source to the terminal to connect up to the motor on both sides. So there's that in addition to the wide trace that I have. But that's the additional copper that I've added, and it all seems to be happy. Let's see, let's put this here. So we have down here our two timing, or FET driving circuits. The monster driver, John Stone, wonderful design, far superior to anything I've ever thought of. Now, one thing we are doing in place of the neon across the drain and source of the FET for protection, this is an experiment back here. I've got 4 batteries with backwards diodes across the drain source, and we're seeing if possibly we can charge these batteries. This 5th battery over here is in fact running the John Stone monster drivers, and of course the whole thing is being ran by my Arduino, just to show you that it can run. Well, actually, let's show you this first. Coming off the positive of all the motors, we're running down here on this wire. We go through a current meter just to show you that, and then off down to our batteries down here, and of course come back up to negative. We got 4 switches on each gate, so we can turn them off, emergency, type thing, and we're coming up here. So right now they are off, so I'm going to power up the Arduino and show you that by varying this pot I can get the little individual gates to fire in the sequence that they'll go in, and of course I can turn the pot up faster and faster until they appear to be on, but in fact they're just being turned on and off very rapidly. So I'll preset it to somewhere I know the motor likes to run. Right at the moment I'm using the quad blink program in this. Tomorrow I hope to run it with the other version of the program to see a comparison difference. And of course we have 0 amps on our amp meter and 75 volts on our batteries. Oh boy, oh boy. And what I'm going to do is sort of aim up here at the motor and then flip them all off, because of course when it first starts there's a bright exciting spark, but that's to be expected. But it quiets right down. There's not any really spark at all. Anyway, during the run what I'm going to do is I'll pan down here. I'll show you the average current that it's drawing, and then I'll come back up over here and I'll plug in this 100-watt light bulb into the generator head, and then we'll come back down here and we'll see how much current it's running. So that's sort of the game plan of this real quick thing. Oh, and of course the other thing we'll do is we have our RPM meter here, and we'll aim it at the shaft and see how many RPM it's turning. It'll be around 3600 at the voltage that I got here, 75 volts. Okay. So we are ramping up with the motor, and I'm going to switch on all the grounds. So it's a little noisy, but I'll try to describe what I'm doing as it goes. So here we go. Okay, so the thing was turning about 3600 RPM, ran a 100-watt light, didn't have too much of a current increase while doing it, and it's down to 74.2 volts at the moment, but actually I've noticed that after the batteries rest for a minute, the voltage starts to recover. In fact, you already see it's at 72.4.3. We'll just watch it a minute longer, and up 74.4. It's going back up. Can't say enough for the Johnstone drivers. They are superior. They work really work great, and so hopefully tomorrow I'll stick in the other version of the program into my Arduino here, and we'll run similar tests. But I've already recorded, not on this video, but prior to it. Of course, I had six batteries here for the 74.5. That's went up another tenth. Volts, and actually I'll be posting a chart. I ran it with 1, 2, 3, 4, 5, and 6 batteries for all the way from 12 volts to whatever, and I'll show the RPM and current readings for all those. And tomorrow when we're running 2, I hope to put more load in it than just a 100-watt light bulb and see what that does to the current draw. Didn't really seem to affect it too much now. You couldn't even, when I plugged it in, barely a perceptible change in the RPM, as you probably heard. So let me get this posted, and tomorrow we'll do more. So UFO, this is a wonderful design on the motor. Works great. Johnstone, your board works great, and the only thing different in my setup to right at the moment is just my experiment for how to not use an NE2 across the drain source, but use some batteries and see if they'll charge up. Don't know if that's good yet or not. Haven't studied it long enough. We'll do a longer motor run and see where all the individual meters go from there. So that's where we are today, team. I'll post this and go from there. Thanks a lot.